Alright, today we're looking at our second lesson, and we're actually going to be solving inequalities in this lesson. By the end of this lesson, for this first part, we're going to be solving inequalities using addition and subtraction. Much like when we were working with equations, there are properties that allow us to manipulate inequalities, like the addition and subtraction equation. So basically, just like with the equations, we can add or subtract the same number to both sides of an inequality and the statement will remain true. So for example, 3 is less than 8. If I was to add 2 to both sides, we'd have 5 is less than 10. But because I added 2 to both sides, it still remains true. Same thing, if I have A is less than B, if I add the same amount to both sides, that remains true. And then 9 is less than 12, same thing. And then the key to remember is that this also works for any inequality symbols, not just the less than. So we want to solve and graph our solution, and we're just going to justify the steps that are used. So here we have x plus 12 is less than 20. So if I'm solving for x, I'm going to do the inverse operation of adding 12, and I'm going to subtract 12 from both sides. So this would be the subtraction property of inequality. And now here the 12s will cancel out, and I have x is less than 8. So now I'm going to go ahead and draw an open circle at 8 because the value of 8 is not included as a solution, and my arrow is going to go to the left. Now why don't you go ahead and try this one on your own. So here we have d minus 5 is greater than negative 7. Because we're subtracting 5, we're going to go ahead and add 5 to both sides, and this would be the addition property of inequality. And now the 5's will cancel out, and we have d is greater than, well, negative 7 plus 5 is going to be negative 2. So I'm going to go ahead and draw an open circle at negative 2. The values are going to be greater than that, so it should go to the right. Now let's look at another example. Here we have n, we're subtracting 3/10. I'm going to go ahead and add 3/10 to both sides. These will cancel out. N is going to stay there. 3/10 plus 9/10 is going to give us 1 and 2/10. So here if you look on our number line, we're just going to kind of approximate where 1 and 2/10 would be. So we'll be about right there. So I'm going to draw a closed circle this time because it's greater than or equal to. And if it helps, remember you can flip around your inequality sign. These are the same. N is less than or equal to 1.2, so my arrows are going to go to the left. If you ever can't remember, just pick a value and see if it's true or not true. So for example, if we wanted to check, we could simply use 1. So if I had 1.2 is greater than or equal to 1, that is true, so we know that 1 is included in the solution, which also tells us the arrow goes to the left. Now, just like we did with equations, where we also solved using multiplication and division, we can do this with inequalities as well. Alright, so we have properties of inequality of multiplication and division. So if we multiply or both sides of an inequality by the same positive number, notice this is a little bit different than adding and subtracting. The statement will remain true. So here if we multiply both sides by 3 or divide both sides by 5, and once again works for all inequality symbols. So now here we have 7 being multiplied by x. So to undo that multiplication, we're going to divide both sides by 7. And here we have x is greater than, well, 42 divided by 7 is 6. Negative divided by positive is a negative. So x is greater than negative 6. So we have open circle, arrow going to the right. Our steps here would be the multiplication property. Oh, not multiplication property, because we're dividing. It would be the division property. So you try this one on your own. So here, once again, because we're taking 5 times q, I'm going to go ahead and divide both sides by 5. This is going to be the division property again. 50 divided by 5 is 10. Negative divided by positive is a negative. So negative 10 is greater than or equal to q. So we're going to have a closed circle. Negative 10 is the biggest, so our arrow would go to the left. Remember, or we can flip this around. Either way, it's open towards the same numbers. Now, the most complicated part about solving inequalities when you're multiplying or dividing is that if you multiply or divide both sides of an inequality by a negative number, the resulting inequality will not be a true statement. We will need to reverse or flip the inequality symbol to make the statement true. So we're going to look through some examples of this. So here, if we multiply both sides by a negative number, so for example, 8 times negative 2, 4 times negative 2, negative 16 is no longer greater than negative 8, so you notice the sign was flipped from the original. Same thing with division. We start with 12 is greater than 4, but if we divide both sides by negative 4, negative 3 is no longer greater than negative 1, so the symbol gets flipped around. Once again, this is true for all inequality symbols. There is one word of caution though. We do not change the direction of the inequality symbols just because we see a negative sign. For example, 4x is less than negative 24. Here we would be dividing both sides by a positive 4, so x would still be less than negative 6. So it's only when we're multiplying or dividing both sides of the inequality that we flip or reverse the inequality symbol. Alright, so for this first example, we have negative 12x is greater than 84. So here, I'm going to go ahead, because we're multiplying, divide both sides by negative 12. These cancel out, and we have x. 84 divided by 12 is 7. Positive divided by negative is a negative. Because we multiplied or divided both sides by a negative number, that inequality symbol is going to switch. So now it's x is less than negative 7. Draw an open circle at negative 7. Arrow is going to go to the left. Alright, so now here are a couple for you to try out on your own. So why don't you go ahead and pause the video, try these out, and let's just check out our work when you're done. Now this first one, we have 10 is greater than or equal to negative x, but remember this is really negative 1x. So if I divide both sides by negative 1, 10 divided by negative 1 is going to be negative 10. Here this is going to be just x, but because I'm dividing both sides by a negative number, I'm going to flip my sign around. So x is actually greater than or equal to negative 10. So close circle at negative 10, and our arrow is going to go to the right. Here, because we're multiplying again, I'm going to divide both sides by negative 0.25. Okay, on this side we're going to be left with just h. We're dividing both sides by a negative number, so our sign is going to get flipped around. And then we just take 4.25 and we're going to divide it by negative 0.25. And we get a value of 17, but it's going to be negative. So h is greater than negative 17. Go ahead and draw an open circle, and then our values are going to be to the right.